Okay, so I want to model what it's like when you have some interference and some standing waves in my long slinky of science. And so what I'm going to do is I have this long slinky, so essentially I have this slinky here, and it's fixed here on this end. So it has a fixed end. And I'm going to oscillate it up and down. And what I'm going to do actually is I'm going to send a wave pulse. So initially I'm going to send one wave, and it will eventually hit this side and come back. Okay? So it actually comes back down this way. So I can try to show that to you. My long slinky of science. So I'm going to send one wave pulse. I'm going to send it with an amplitude upwards, and I want you to try and watch how it comes back to me. So it's kind of hard to see, but I sent the amplitude up and it came back down. Now, that's if I send one wave pulse, but what happens if I send a continual wave pulse? So what I'm saying is I send my wave pulse and it goes and it bounces, and when when this first one's bouncing or coming back, reflecting back, what happens if I send another wave? Okay, then these two are going to interfere with each other. And I'm going to do this continually. I'm going to keep sending waves, and they're going to keep reflecting. And when they keep reflecting, they're going to have what's called a standing wave pattern. So there's just going to be this pattern of a set interference. So the first standing wave pattern is not very exciting. It's got a pretty low frequency. And here's the first standing wave pattern. I know, so exciting, right? So if I were to visualize this on the board, that first standing wave pattern is just like my slinky going back and forth, back and forth. And so what you don't notice, or you don't think about the nuance of this, is I actually have a couple points here that don't seem to really be moving at all. Okay? They're not moving, and those points of no movement are called nodes. No movement, nodes. And then I seem to have a point here that moves huge. It goes up and then down, up and then down, and that is called an antinode. And in terms of interference, nodes are points where I have destructive interference, and antinodes are points where I have constructive interference. So again, let me model this for you. First one's super boring. It's like I've got two nodes. My two endpoints are nodes, and that point in the middle is an antinode. I've got maximum movement. Now, if I change my frequency, so I'm going to change the frequency at which I oscillate. I'm not changing my medium, so my speed of the wave is not changing. The speed of a wave depends on the medium. But I'm going to change my frequency. So V is equal to lambda F. If I increase my frequency, it should also change my wavelength, okay? So I'm going to go for the second standing wave pattern. So you can see there's actually 3 points of no movement. I still have the two endpoints, but now I have that point kind of in the middle that doesn't really seem like it's moving. Ooh. So in this one, I'm going to hold on to my key here. In this one, I had this kind of point here, point here, point here. Those are my nodes. And then I had two antinodes, these 2 points here that seem to have a maximum amount of movement. So these are like my antinodes, and then these black points are my nodes. Now, you can keep going with the process. Like I can do my third standing wave. So my third standing wave, now I have 4 points that don't really seem to be moving, and I have 3 points that are moving maximum amounts. Okay? So in this case, it would be node, 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 antinode, antinode, antinode. Okay? In music, these are known as the harmonics in terms of the increasing frequency and how you can actually look at the mathematics of it and how it relates to the wavelength and actually the length of whatever it is you're oscillating. Okay? So notice for this, for my slinky, and it's the same thing for like anything with a fixed end at both points. If it's a fixed end, I have to have a node at each point because it's constrained. So there can't be like huge movements when I'm constrained. And so for strings, there's always a node at the end. Now, if you have air columns, that can be a little bit different because your air may not have a fixed point over here, and so you could have an antinode here at the end. Okay? So that should give you just like a little bit of a primer on interference and how that interference can cause standing waves and how we would have these different harmonics for our standing waves.